Alrighty. Morning, everybody. This is my presentation on my AI sales assistant and hopefully how I'm going to automate lead tracking and proposal generation. So first, I'm going to talk about the actual problem I'm trying to solve, why I think that's important. Then I'm going to talk about how it's actually going to work and some research that I've done. And then I'm going to tell you about how I plan to actually implement this and finish it up by the end of the semester.
Nice preview.
Thanks. So the problem statement is in HVAC sales, lead information is often spread across texts, calls, and notes, which makes it difficult to organize data, but also prioritize leads and respond quickly to customers. As you guys know, sales in any facet is a relationship-driven field, and relying on memory when you're talking to clients, and you might forget these small details that really matter, which leads to less trust, leading to less credibility, probably leading to you losing a client. So some real world solutions that I'm trying to implement to try to kind of combat this problem is the faster proposals leading to winning over or closing clientele. And after I get these faster proposals, I hope to give follow-up reminders with this, not with the full proposal, but just like, hey, let's keep the ball rolling. Don't forget about this guy because it's a pretty solid lead. Some small contractors in the HVAC field lack AI tools, and I think, I'm a college student. If I actually made this and made it well, it would be pretty accessible and pretty cheap for these smaller contractors. And again, it keeps all these notes from calls, texts, emails, Zoom calls, like in-person meetings, keeps it all organized without hindering the scalability or trust of the overall business. So now that I've talked about my problem, why I think it's important, let's talk about like the course themes that I'm kind of covering. I'm talking about limits of human versus machine vision or machine learning. I'm talking about classification and using the implementation of support vector machines. And then I'm also doing feature extraction, kind of detecting the intent of the given lead. And then I might do some dimensionality reduction with the implementation of principal component analysis for just overall note summarization, kind of making sure like this is important, but these are like the most important things about this client. So how it works. First, we're going to take this raw input, all these notes that we've gotten from all the calls, texts, all that good stuff. And then we're going to do feature extraction. So we're going to take the urgency of the problem, the age of the actual HVAC system, and then whether it's a repair of the HVAC system or a replacement, among other things. And then we're going to do a feature vector, which we're going to take all these features that we extracted and put them into a vector of numbers for the client, and each lead becomes a vector of numbers under those categories. And then this is where I'm not sure if I'm going to use a principal component analysis algorithm to reduce dimensionality while preserving variance. I'm not sure if it'll overcomplicate things for me because, like most of you, this is my first time doing this. And then I know I'm going to use support vector machines for the classification component. As you guys know, it makes like a hyperplane. Like these are all the bad clients, or not the bad clients, but like the bad leads that probably won't give you much money. And then these are the ones that you want to focus on. Pretty simple, but it works. So now that I've told you how it works, let's look at some research that I've done throughout this semester. So first I looked into some business-to-business lead scoring models with Laura Gonzalez Flores, who works at Universidad Nacional Autónoma de Mexico. And she predicted which sales leads will convert using real business-to-business CRM sales records. And CRM are just customer relationship management systems. And a lot of HVAC companies use them as well. She used logistic regression and gradient boosting, and I'm not using logistic regression. Instead, I'm kind of focusing on SVM classification, but that is a different alleyway I could take, I guess, to solve this problem. And she found that machine learning models outperform the manual scoring, which, I mean, doesn't really surprise me too much. But it is convenient because it kind of analyzes how machine learning models can actually deduce what's most likely to be, or what lead is most likely to actually convert. Next, I looked into Miguel Wu's work at the University of Ottawa, and his research group kind of compared traditional and machine-based lead scoring using a multitude of, I think it was like 44 or something, prior research studies. And he also used logistic regression in addition to SVMs, which I'm using the SVMs. I think he did both separately. And he found that machine-based lead scoring kind of improves conversion rates. While it doesn't actually integrate into an automated CRM workflow, which is kind of what I'm aiming for at the end of this semester, hopefully, it still, again, gives me some good insight into how machine learning helps, especially with support vector machines. And then finally, I've looked at the work of Cristina Ledro at the University of Padova in Italy, I believe. And she looked into how AI systems can improve CRM systems using conceptual customer data from a conceptual CRM system. I think it was multiple, actually. And she used support vector machines, again, as well as logistic regressions. So as you can see, the logistic regressions and support vector machines both work for this. And these strategies kind of helped personalize as well as accelerate the CRM workflow. So talked about research. Let's talk about the actual professional value that this project brings. Obviously, HVAC sales, maybe construction sales, but I think you can kind of tweak this to just meet any sales field in general. And I mean, I'm demonstrating hopefully and definitely learning a lot about applied machine learning, feature extraction from text rather than images, which I know a lot of you guys are doing, and then the application of support vector machines and maybe some principal component analysis. And I hope by the end of this semester, I'm able to deliver a functional prototype in at least Google Colab, and maybe I'm able to implement that into some CRMs. Sorry. All right, project timeline. So this week and next week, I'm collecting some sample HVAC lead data, so that I can make my own data set, so it's not too complicated. And then 3 and 4, I want to focus on the feature extraction and feature vector, because again, first time kind of doing this, I want to make sure that it all runs smoothly. And then finally, I want to, through weeks 5 and 6, I want to implement the support vector machines and maybe the principal component analysis. And then week 7, hopefully I'll have everything done. I'll be able to build up the demo, kind of make sure it actually all runs smoothly. So obviously there's going to be some risks and mitigations. I already addressed the messy real-world data. It's probably a pretty high risk, again, because of all the notes that are coming from everywhere. And I want to start with a structured data set in order to mitigate that. And I think the other two are also pretty high risk, just because they both kind of go hand in hand. My model might underperform just because I have some time constraints, just like Dr. Gleason said right before this. One person doing all this work over 5 weeks. It's a little overwhelming, especially for my first time kind of doing all this stuff. So I think if I begin with like a simple core model instead of making an entire system, it'll help mitigate that as well. Just to recap, talked about the problem, talked about why I thought it was important, and then I talked about how the actual AI system will work. Then I told you a little bit about the research that used the SVMs as well as logistic regression in order to kind of prove that these machine learning and lead scoring models work. And then I talked to you about my plan for the rest of the semester and how I'm going to kind of mitigate the risks that I think I'll run into. Thank you.
All right, I want to hear what folks think. Is this going to be like an agentic AI kind of thing?
Yeah, that's what I'm trying to make it like. Yeah.
Oh,
was gonna say, so on the Choose Your Own Adventure assignment, I used a data set that was kind of doing something similar as like predicting a decision.
Yeah.
And I actually once we were running like the accuracy results, I also found that KNN, the
KNN?
worked really well. It actually had a high.
Yeah, I was thinking about using a clustering algorithm.
Yeah, because you can cluster based on what is most important to make the sale, right?
Yeah.
Yeah, I have on here nearest neighbors might be a good way to go. I want to talk a little bit. A lot of these literature, these researchers are using logistic regression,
Mm-hmm.
and we touched on it so quickly that I'm not expecting us to remember. But logistic regression is basically making a binary decision. Yes, no, true, false, expensive, not expensive, follow up or don't follow up,
Yeah.
right? It's not trying to do like predicting the housing price. It's trying to predict maybe whether it's an expensive house or a cheap house. So it makes sense in a recommender system for sales that a lot of these employ logistic regression. Because at the end of the day, they're saying follow up with this client or you're probably not gonna make that commission. I don't think that's because it's not like whether we pick a nearest neighbor or an XGBoost or support vector machine. It's not a decision we make because it's what fits the hyperplane, so to speak. It's a decision we make because of the actual use case. Does that make sense? So I'm not super surprised to see logistic regression all over the place. I think before we think about which algorithm we plug in, we need to have a really firm sense of what the data set is.
Yeah.
Because we draw our kind of hypothesis of how we're going to solve the problem by the data. So I'd like to hear a little more when you say that you're going to get an HVAC lead database
Mhm.
or maybe an Excel spreadsheet of different things. Do you have one in mind? Where would you get it? I want to hear more about that because for me, we can't do anything else until we have a data set.
Yeah, I mean, I have a couple buddies that work in HVAC right now, so I was gonna reach out to them and see if I could get some data from them,
Okay.
and then
Do they
also do
work
some research.
Do they have sales departments as
Yeah.
well there? Okay.
Yeah.
So you're trying to get the data that is a spreadsheet that they're looking at from
Yeah.
a sales perspective. Yeah, I want to see that ASAP, ASAP, ASAP. Because thinking about, the dimensionality of that, what are the features, and then what
Mhm.
features are going to be features that are useful or not useful, and then
Gotcha.
what features are going to be consistent across companies.
All right.
Because if you're trying to create a product that lots of people in an HVAC space can use, well then we need to be analyzing similar data sets. So in fact, it's not just that you're making a recommender system, in a large part you're training them how to input data as a function of sales.
Yeah.
Right? And so I would really want to see that data set ASAP, and I'm sure we can do something cool with it.
Okay.
Right? But you might find that your buddies are sending you radically different types of spreadsheets.
Yeah.
Because there's no one way to do it.
Yeah.
Right? And then one person is probably like, yeah, I've got a bunch of receipts in my truck, and I write down whether I think that they'll spend money or not, and he's like rummaging around and he's giving you just a bunch of things on paper.
Yeah.
And that, ideally, we want to stay away from that because you'll have to translate that into a data set and we just do not have enough time.
Yeah.
Does that make sense?
Gotcha.
I like this though. Did you have another question?
Yeah, I was just gonna add too on the data set that I used, 'cause it was basically determining if people were likely to put down a deposit for a
Yeah.
for a loan
Yes.
or something for a bank, and I was thinking that's kind of a similar thing. Like you're seeing if somebody's gonna commit financially to something in a way, and one of the things that they looked at was it had 16 features, and the big ones were like job status, if they were employed,
Yeah.
if they were married, and then if they owned a house, and I feel like that's something too that
Yeah.
Yeah.
that thing and look at what the features they were. That would probably help.
I think that's excellent feedback, Jackson. And in fact, HVAC is a use case of this, but we see these systems employed a lot in
Yeah.
finance, determining whether you'll get that loan or not. And there's so much data out there that's openly accessible that people are turning. So if we get to a point where our HVAC data sets are really not what we need, I would encourage you to pivot to just finance.
All right.
And we can pull off there are so many of them on capital, right?
Yeah.
And we can pull off a data set where we already have the consumer should get that loan or not from an algorithmic perspective, rather than a banker who's just like, I've been doing this for 30 years, right? So I like the HVAC use case. I think is I often am looking for narrow scopes. I mean, that's what we just talked about with Asher's project. I'm like, let's find the niche, and you've got the niche. I just don't know if the data sets that
Yeah.
you'll get will have the type of dimensions that are actually useful.
Yeah.
Does that make sense?
I completely
And
understand
it's fine
that.
if you end up running the analysis and it turns out it doesn't work. In large part, it might be because we don't have the right data.
Yeah.
Right? And so sometimes we're thinking about the ways to collect more data. I mean, Ashford, you're kind of thinking through that in terms of like sensor networks that they could use to get better data about smell, right?
Yeah.
Yeah, I like this. I think let's not lock in to say that we're going to use a support vector machine yet or
Yeah.
anything like that.
Okay.
Let's lock in on finding some data and taking a look at
Gotcha.
data. We've got at least 2 full weeks after the semester dedicated to just working through your projects in class, right? That makes sense? Cool. Another round of applause for that.
All right.
Thank you. This is our last one.
Oh shoot.
Okay, so
W comms.
we do a couple things here, Dan.